Hello everyone, I am Ariba representing Team Dev Bharat for Smart India Hackathon 2025. Our problem statement is focused on agriculture, food tech, and rural development under the student innovation category. Every innovation comes with a problem, so let us understand the challenges faced by Indian farmers today. Today, farmers face three major problems. First, low awareness and lack of guidance. Most farmers don't know about subsidies or miss deadlines due to lack of digital help. Second, dependency on middlemen. Farmer depends on agents which leads to unfair pricing and no direct buyer access. And third, poor internet connectivity which cuts them off from schemes and digital markets. Our solution addresses all these challenges. Through a smart subsidy guide, farmers get reminders and checklists to never miss benefits. A direct marketplace lets them sell crops directly to buyer, eliminating the middleman. IoT based offline access ensures connectivity even without internet, and the multilingual support makes it easy for farmers across India to use. We are using a strong tech stack React, Node.js, Python, cloud services, and IoT devices like ESP32 with LoRa for offline communication. The platform includes a farmer dashboard, AI driven scheme, suggestions, and a decentralized marketplace that works even in low connectivity regions. Our solution is practical and scalable. It uses readily available technologies, Aadhaar based authentication, and aligns with government policies like Digital India and Atmanirbhar Bharat. It's farmer friendly, multilingual, and can expand through modular IoT deployment across villages. Dev Bharat creates threefold impact. Socially, it empowers farmers with knowledge and access. Economically, it ensures fair prices, easy subsidies, and affordable IoT driven smart farming. Environmentally, it promotes sustainable practices and reduces carbon footprint by enabling local and direct sales.
Welcome to the Kisan demo video where I will explain the hardware part. Here in the hardware we are using ESP32, a SD card slot, a OLED display, the LoRa 02 module and the default antenna. Here is a one mode and here is another node which is connected through a power cable to my laptop. Here is another power cord connected to my laptop. So here I am going to show you how a connection is going to establish between two nodes of the project. So here is one and here is one. As you know, ESP32 is capable of hosting a Wi-Fi. So I am going to connect one Wi-Fi through my phone. Here as you can see in the display it is showing the IP address and the device name, that is KisanMitra1. So I am going to connect through KisanMitra1 through the password. As you can see, it is securely connected to the KisanMitra1, and as you will see, there is no internet connection here. It is completely internet offline, and as there is showing a IP address, I am going to type the IP address here. But it is 192.168.11.1. It is 192.168.11.1, and it is going to take me to the website of Kisan Setu. As you can see, here is the website of Kisan Setu. Here also in the website, here you can see the temperature, humidity, and air quality, because we are also using a air quality sensor. Here is the humidity and temperature sensor. It is DST22, and air quality sensor is MQ009. And for network connection establishing, here we are also using another LoRa module. So the connection between two different modules. First, I have connected the first module to the Kisan Setu 1 Wi-Fi without an internet, and I am going to the second with my laptop. As you can see, here is another Kisan Setu 2 where has no internet connection and is already connected. And as you can see, my laptop has no internet connection. Now I am going to open the IP of the second for Kisan Setu, which will, these two nodes are will be kept apart from each other, and the range is around 300 to 200 meters. So if I type the IP in the URL, and the IP for the first IP is 192.168.11.1, the second IP will be 192.168.12.1. As you can see the IP here, I will enter. And it will redirect me to the website. As you can see, I am accessing Kisan Setu 1 in the phone and I am accessing Kisan Setu 2 from the laptop while having no internet connection, only connecting to the Wi-Fi of the different ESP32 modules. So as let me show you, as I am a farmer, I will type my name is Ravi and I'm a farmer and I will join securely. Join securely because this website contains encryptions and only the secure and the device who have the permission of the key can access the website and communicate between them. And as I have joined Ravi as a farmer in the phone, I can say to one and I will join Sub as a buyer. And here I will type a message. Hello, Ravi. As you can see, I send it here. It will show here that hello Ravi, Kisan Sub the buyer sent a message. And as I'm the farmer Ravi, I will type, as I can also type. As you can see, I take a message Ravi that what you want to buy. So and as you can see, he or she may receive the message through it. And here it shows that it's establishing a connection between two Wi-Fi modules through LoRa, which is using 432 MHz frequency to send the packets to another LoRa. And here we are using only two LoRa modules as two different nodes. And to make a network, we will use many kind of ESP32s in different positions to establish a peer-to-peer architecture communication between different ESP32s. And here on the website, it is still developing. And if you can see here, as you can see, both the devices showing temperature, humidity, and air quality. Here and the network is established. And if I ask the AI about something, let me say potato. As you can see, the AI is giving me answers. And to can see in the display here is also showing the number of messages sent, number of messages received, and also another thing is the V. V means violation. How if any intruder try to intrude in our network, it will show that someone is trying to intrude, and so increase the number. This is the OLED display, and this is the complete user interface. And here, if I take to home, schemes, market, security, here are all the options. If I select an option, I will redirect to the main page where internet is accessed. And if one of the node here is connected to internet, the complete network of ESP32 will have access to internet because one node is connected to another node, and they can share data between them. And that's it for the demo of our project KisanMitra.
Let us have a look on the working of our prototype. Our platform provides farmer to register by entering his credentials such as name, date of birth, Aadhaar, and mobile number for a secure registration process. After successful registration, he will be asked to enter some details and documents which will be used further ahead to fill the forms. By completing uploading of his Aadhaar, ROR, land documents, bank passbook, and he will be redirected to his farm analytics dashboard where he can have a look at various information and real-time data. He can also see live market prices of all regions in India. He can have a look at the weather dashboard and see his current weather report in his area. Moreover, he can browse through different crop yields through different parts of region by our graphs and chart. He can access to our subsidy calculator feature by using his land acres details, his crop type, annual income, and state region. According to his entries, our platform will show schemes suitable for him out of those where he can select only one at a time. At every scheme he selects, he will be provided with a document checklist and eligibility requirement to meet the subsidy scheme eligibility. Moving on to the product section where he can actually list down his product or items in our virtual marketplace, eliminating the middleman that connects farmer with the buyer, which helps him compare real-time prices. Our AI-based recommendation is helpful for farmers as it recommends subsidy suitable for him and also guides him step by step. He can access his own profile by entering his login credentials, where he will be checking out the training checklist, and after every step, he is required to submit a proof of record through the portal, which reduces physical intervention and complex paperwork. Alongside, he will be access to a YouTube tutorial link for reference, which he can use to implement his training. Also, our portal is implemented in multilingual theme where he can access our website in his own desired language, irrespective of his language or digital literacy. After successful completion of his steps, he will obtain a government certified certificate which he can show this to his nearest Gram Panchayat office and avail the scheme. Also, our feature Krishi Sahayak Kisano Ka Saathi enables farmers to ask questions through our voice to text or text to speech support in three languages Hindi, English, and Odia. Let us have a look at the buyer portal where the buyer registers himself there and normally browse through all the products, add to his cart, and proceeds to buy, ensuring smooth trade.